All right, so I need now to define what is reference angles, because for certain angles, we can compute all trigonometric function in exact values. So basically, a reference angle is an acute angle, meaning between 0 and 90 degrees, that is formed with the terminal side of the angle and the horizontal axis. So all this, if you read, you're going to get to the information what it is actually in the end. And remember that acute angle means something between 0 degrees and 90 degrees. A reference angle is always going to be something between 0 and 90 degrees. What it is the amount of angle formation, measurement of the angle between the terminal side and the horizontal axis. Now, if I have an angle in the first quadrant, where it means the terminal side is in the first quadrant, angle and the reference angle coincide. That's only for the first quadrant, and that's what you see there. Now, for the second quadrant, whatever is the position of your terminal side, as showing here, the reference angle is something between that terminal side and the horizontal axis. Notice that the angle is here. It's all this measurement according to the drawing in green. So the measurement of the angle is the green part, but because the terminal side in the second quadrant, you look at that formation of a new angle, which is the terminal side and the horizontal axis. The reference angle here is this measurement. So this is the reference angle. So not always we're going to have that the angle and the reference angle are the same. That only happens for the first quadrant for the obvious reason. Here in the third quadrant, this is the terminal side. So the angle is this. The reference angle is this measurement here, which is not the same, right? So the reference angle is the amount of angle between the terminal side and the horizontal axis. So the reference angle is this. For the first quadrant, that means that if the angle position somewhere in the first quadrant, so as it says here, it goes from here to here, this is the angle. The reference angle is going to be this measurement, which is between the terminal side and the horizontal axis. So this is the reference angle. I have, for number one, that the angle is 160 degrees. The terminal side of the angle in standard position is in the second quadrant. So since the angle of 106 is this, all you need to do is to find out what's this measurement here. Remember, it's an acute angle. So in order to find that measurement, notice that you know what is this. This is the terminal side of 180 degrees. So if I take 180 degrees and subtract that angle of 106, what's left behind is exactly the green part, the measurement that I need. So I do 180 minus 160. The result is 20. Notice that 20 is a positive angle between 0 and 90 degrees. This is acute angle. So this is the reference angle for 160 degrees. So again, you have your 180 degrees right here. So this is the angle of 180 degrees. So if you subtract from that your 160, which is this, what is left behind is what you need. So now let's do number two. So I have that the angle I'm looking at is 314. Okay, that means that the angle is going to be in the fourth quadrant. So I'm going to sketch somewhere what I think is 314. Again, I'm not going to be very precise this time. Notice that up to here, you have 270. So obviously you need to go a little bit beyond to get the 314, okay? Somewhere about the middle is gonna be the 314. So this is the angle theta, which is 314. Now, what I need to get is this amount of angle. Again, the reference angle is between the terminal side and the horizontal axis. Notice that it's never going to be the other direction, right? Why? Because I need an acute. So it cannot be this, because it's going to give me more than 90 degrees, so it's not acute. So instead, we're looking at that direction where I highlighted in gray. So that is actually the reference angle. So the reference angle is, so if I take this terminal side right here, hold on, I want to do a different color to highlight that. This is the terminal side of 360 degrees. So if I take the angle 360 and subtract 314, I get an acute angle, a measurement of an angle that's positive between 0 and 9 degrees. So that is my reference angle. So the reference angle is going to be the 360 minus, and then the original number, which is 314. So the reference angle for number 2 is 46 degrees. And again, I know it's correct because positive between 0 and 9 degrees, as any reference angle should be, okay? So the reference angle of 314 degrees is 46 degrees. Now we're gonna check something in the first quadrant. So angle of 27 degrees. So it's gonna be somewhere here, first quadrant. So this is theta, 27. Now, because the terminal side of theta and the horizontal axis, it means that theta itself is the reference angle. What you can do that to make sense in terms of operation, you can take 27 subtract 0 because the angle 0 has this as a terminal side. So this is the terminal side of 0. So 27 minus 0 is 27. But really, if you looking at terminal side of something between 0 and 9 degrees that is in the first quadrant, so it's going to be itself. So the reference angle is itself. So theta prime is 27 as well. It's because the terminal side, I'm using basically implying that I'm using the terminal side of the angle 0 degrees, and 27 minus 0 is still 27. 239 degrees, so that's the third quadrant. Okay, so starting from here, rotate somewhere in the third quadrant. Again, I'm not going to be very precise, but you know it's in the third quadrant. The terminal side with the horizontal x has a formation, which I'm going to highlight in a second. So the formation I'm talking about is this. Right? I need something between 0 and 9 degrees, so that's why I'm not looking this. Why? Because this is going to give me an angle greater than 9 degrees, so it's not acute. So that's why I'm using, it's basically the smallest angle between the terminal side and the horizontal x. So to find that angle, theta, so this is theta prime, what we're going to do for theta prime, notice that I'm also going to use 180 degrees. So this is the terminal side of 180 degrees. But in my subtraction, I'm going to first put the 239. So 239, because it's bigger, it goes from here to here is bigger, and then subtract the other part, which is from here to here. So I have then 239 minus 180 degrees, and that's 59. So theta prime, meaning reference angle, is 59 degrees. Okay, let me do negative 7 pi over 4. So first step, sketch the angle in standard position to help you think what kind of subtraction or addition you need to do. I know I'm going to rotate in the negative direction. The question is how much I'm going to rotate. So notice that pi over 4 is like a quarter of a quadrant. So I'm taking 7 quarters of a quadrant, basically. So what I mean by that, by the way, this is not yet the sketch of my terminal side. So here is pi over 4. So every half of a quadrant, which is 45 degrees, is pi over 4. But that's not the angle I needed to draw. I need actually to draw negative 7 pi over 4. Let me remove the pi over 4 so you know that. If I subdivide the quarters of every single quadrant, okay? So start from here, rotate in this direction. So here I have 1 negative pi over 4. Here I'm going to have 2 negative pi over 4. Here I have negative 3 pi over 4. Here I have 4, oops, not right. Here I have negative 4 pi over 4. Here I have negative 5 pi over 4. Here I have negative 6 pi over 4. And here I have then 7 pi over 4 in the negative direction. This is negative 7 pi over 4. So this is the terminal side for negative 7 pi over 4. And now I need the reference angle. Now the reference angle is this quantity here, is between the terminal side and the horizontal axis. So that's going to be my reference angle. So how do I compute that? Well, I know I have a negative angle. So if I take positive 2 pi, which is like positive 3/6, and remove all this negative direction that I did, I will get something positive, which is going to be between 0 and 9 degrees, but it's going to be described as a positive angle in radians. But notice you should anticipate already that this value should be the same as 45 degrees, which is half of the quadrant, as I mentioned. So it should be the pi over 4. But let's do the computation anyway. If you didn't understand why I get pi over 4 as a reference angle, it's just because I divide all the quadrants in half. Each half is pi over 4, and that's how I form the negative 7 pi over 4. So I take my angle, negative 7 pi over 4, and add the equivalent of 360, which is 2 pi. Why am I adding? Because I needed to get a quantity that's positive. So if you subtract 2 pi over 4, you're going to just get more negative numbers. And again, that cannot be a reference angle. Okay, so I just need now to add the fractions. And by the way, the fraction here is the same thing as if I take 2 pi minus the original angle. It's the same thing. But I want you to think that the denominator is 1. And in order to add fractions, you need to have the same denominator. So let's multiply top and bottom of 2 pi by the number 4. So I get the same denominator. So the reference angle here is now 8 pi over 4 minus 7 pi over 4. Now that I have the same denominator, keep the denominator, subtract on the top, which is pi over 4, 1 pi over 4.